Hello everyone and welcome to the first video for Oats channel. If you've been following our publications on Dev2, Substack and Medium, you can have a slight idea of what Oats is, but I'll assume our first viewers, or as the first time you're interacting with our videos, you are not aware of what Oats is. So this video will specifically be for introducing Oats and what it is in general and some of the features that it packs. So Oats is the open web framework, and it's basically a web framework that's built to allow developers to use simple web technologies to build amazing web apps. And by being the open web framework, it allows for an open ecosystem, meaning if you know Webpack and you know how to configure Webpack, Oats has a very open Webpack configuration that allows you to set up your own loaders, templating engines, and the like. So we'll just jump right into it. There's an article that I'd written already, and I'll just do a quick run through the article so that we just deal with the introduction, and then we're going to have a several set of videos that now we'll get into using Oats, and we're going to be doing tutorials, and we'll have great projects that we'll be building so that we learn how to use the framework. So just a bit of background, Oats has been in development for the past 4 years, or slightly over 4 years. It started on June 2020 as part of a client project, but I was able to detach Oats from the client project strictly so that we can have a web framework that can be used across all web projects. So this project is already live and in production. There is the client site, that is vatsolutions.com, and here's the website, and this website is already running Oats. The source code for the project is also public. You can find it on the description below. The link is also provided in the article. So you can go fork the project, look through the source code, and if you're interested, even start contributing. So let's get into the core bits of it. Now, I've already explained why Oats. We call Oats the open web framework. Basically, with Oats, you can write your web app in something as simple as HTML, vanilla JavaScript, and CSS. Because for Oats, at the end of the day, what matters to it is that it gives you a skeleton that will allow you to provide a web app experience. But in terms of the specific libraries or tools that you use to now achieve the whole functionality of your website, there's a good degree of freedom that you get from the framework. Now, as far as the view system is concerned, Oats uses something called the fragment-based system. Now, all that means is, if you look at the article, there's a few images that I provided for description. So we have this homepage, we have an about page, we have a homepage and about page. And we have the homepage takes the whole screen real estate, and we have the about page, which is split into two. We have the left side, which has a staff member, and then the right side, which has more details about the staff member. Now, Oats will have two key divisions. Look, let's call them view components for the app. We'll have the root view, which is basically the bit of your website that never changes, which in most cases, this will be like the navigation, for instance. So in our example, if you look at the home page, you have the home, we have the home, about, and contact, and this will never change because even when you go to the about page, the home, about, contact, the navigation, basically the nav bar, will not change. But we have the internal view, quote unquote, or view component that will be changing based on which page we are in. So in the home page, we have this my home page text, but when I'm in the about page, you have the left side that has the about, and the right side which has more information about the staff member put right under the about side. So in terms of fragments, we'll have my homepage will just have one fragment, which is showing that whole content from my homepage. And then for about, you can view it in two ways. You can either have about as a whole fragment, or the better way to do it is to have it as two fragments, because you have the left side, which will list staff members. You can see you already have one staff member. And then you have the right side, which will show information about each staff member. So let's say maybe the web app in this case will be structured in such that when you click on a staff member, their info loads on the right. And so we have that form of interactivity with the page. Now, if I'm to give a practical example with VAT solutions, now we have our navigation right here, and we have the content that's down here. Now, this is the homepage, and you have the content that you have in our homepage. Now, that the homepage itself, the content that you have down here is in its own home fragment. And when you come to blog, when you click on blog, that loads a new fragment that essentially loads a new view, and we now have our blog view. It's the same thing that happens when you go to shop, or about, or contact, or home. So how our views are changing and becoming dynamic, quote unquote, based on routing is through the fragment system. Now, there's the code that you use to set up to set up fragments. I'll not dive into that for this video because you have tutorials that actually get into this. But just as an overview, basically to just set up a fragment, there are just three key methods that you need to override. You have the initialize view that will just set up the view for your fragment. And then you have on UI bind, which is called once Oats has actually bound your view to the DOM. And then now you can do stuff like attaching view listeners. And then you have on query params data update, which is a very special function that is used to tell you when parameters or queries in your route change for the same fragment. And so you can have a view or a fragment that reacts, that has its view change or reacts based on parameter changes and query changes in the route. And we'll look at that later. Now, as far as writing your source code is concerned, Oats doesn't have a special syntax or a special language. You can literally use vanilla JavaScript to write any of your app or business logic in Oats. And because you run on top of Webpack, Oats also comes with code splitting and lazy loading by default. And what that means in Oats' perspective specifically is currently, if you look at Rovat's example, for instance, let me just reload the page. Now, we have the home page, which is loaded the home fragment. Now, when I come to blog, what happens? The network is quite fast, so you saw the loading screen for a short while. But what happened was the blog fragment, which is a JavaScript module on its own, was actually a separate chunk that wasn't loaded initially. And when I requested for the blog route, Oats was able to, because of code splitting, Oats was first loaded the JavaScript module or chunk that should render our blog fragment, and then the blog fragment itself was now invoked to render its view and do everything that it needs to do as far as the app logic is concerned. So what this, if you're familiar with code splitting and lazy loading, you'll know that this helps a lot in reducing the initial bundle size, meaning your web app loads faster on initial load, and now on subsequent loads, the client only gets the bits of the app that they need. And the next thing is now, because you're using Webpack and Oats has been created to work in an open ecosystem, you can have advanced project configurations using Webpack. Now, a good example is with templating views, because for instance, with Oats by default, we use handlebars for templating. And handlebars makes rendering dynamic views easier because it takes the format of JSX mostly, sort of, quote unquote, but in the sense that you can replace bits of the markup with data that will be loaded for the markup at that time. Now, despite also using handlebars by default, you are free to use any other templating engine that you're familiar with. And so you can just go to the Webpack configuration, update the loaders, set up your loader for your templating engine, and just use it directly in Oats, because at the end of the day, as far as even rendering views are concerned, Oats' input, or the input that it expects, is a HTML string, not a templating function, but rather HTML string. So you're free to use any templating function and any templating engine that you need. Now, let's get to the bits that are now Oats specific and show the unique things about the framework. The first thing is routing. Now, routing is a default feature in Oats. You can't run or start an Oats app without specifying a route. Now, routing information provided within an array, and the array will typically have, the first thing we'll have is the route, which, and then we'll have a target. The target is basically the fragment where the view rendering will begin. And in Oats' case, this will be the main fragment. And then after that, we'll have the nested child fragments, of which if you have views nested within that main fragment, you'll specify their fragments in order of how they'll be rendered. And you put that in an array, and then you'll be able to specify them. Now, the unique things that come with Oats is, as far as routing is concerned, Oats supports parameters in routing. Now, what that means is you can define your route, like in the example given in the article, as using the colon syntax, as you usually do in Express. And that Oats will understand that this represents a parameter, and Oats will automatically infer the parameter for you whenever it triggers a route that matches the parameters route that you've given it. So for instance, if you had this route, and then you have user 1, user 2, user 3, when you get into your fragment and you query the value of my params, you'll be able to, for this route, you'll be able to get it as user 1, for this route, you'll be able to get it as user 2, and for this route, you'll be able to get it as user 3. And on top of that, Oats also supports queries. So you can also use the standard query syntax that you have in normal routes in the web, and Oats will also be able to infer them and have you dot reference them from the params and queries objects that it will give you inside the fragment. But what you need to note is parameters in Oats or routing in Oats will only support parameters. You can specify a route that also includes queries, because when you're resolving routes, Oats will truncate the queries and then only use the route without the queries. So always your route will be in this format, or if it's parameterized, you'll have the colon, but you can't put the question mark and then queries and have that as a route. Oats will ignore the queries. Now, the main thing, or the main feature that comes with routing now for Oats is something called consent-based routing. Consent-based routing basically means that before a route changes for Oats, which will load a new fragment or a new set of fragments, Oats first seeks consent from the current route to ensure that it can move to the next. So a good example is, let's say you are filling a form, a user is filling a form, and then let's say if they're on their mobile, it's easy to just by mistake swipe to go back, and in often cases you'll lose the data that you had in your form, or you'll have to route back to your form because that's not what you wanted to do. Now, for Oats's case, it will, before it accepts that route change, it will ask the fragments that are rendering the current view to confirm whether they want to exit. And if the user is filling a form, you can check whether the form was submitted or not, and you can be able to stop the routing, reject the request, and tell the user your form is incomplete. And the good thing is the user can choose to just continue with the routing and have their data lost, or let's say just removed from the view, or they can now absolutely reject the routing, and they can get back to their form and finish whatever it is they're doing. So this form of routing mechanism is really helpful in ensuring that you have a good control of the user experience. And the good thing that Oats does is, because you don't want users to always be consenting with every route change, Oats by default has the fragments consenting to route changes. So for instance, if you come to VAT Solutions, if I'm to navigate to shop, there was no pop-up or any form of confirmation that I needed to give the web app for it to navigate to shop, because by default, OT fragments are consenting to the route change. Now, if I wanted the user to, if I wanted to implement consent, now I'd have to do it explicitly. I'd have to override the function or the method that handles consent, and then OTC will stop the routing, have me request for consent because of a few things tied to the user experience, and then if the user accepts the changes, the routing, they're able to move to the next view. If they deny because it was maybe by mistake or anything of that sort, Oats is able to retain the route that it was in. Now, the next thing that we go to is pop-ups, dialogues, and layouts using view panels. Now, we've already talked about fragments, and fragments are basically the main view system for OTC. But then you have these instances where you don't pop up a dialogue, you don't to provide extra information that, let's say, the user gets when they click on something or trigger an event. Now, fragments are used primarily to tell OTC during routing about the main views that it should render. Now, view panels allow you to now render dynamic views after routing has been done based on events. And as I've just mentioned, you can have those pop-ups, dialogues, and any other thing that you want to render. Now, view panels are managed. View panels are important because normally if you're to do such kind of, if you're to render such kind of views, you'd have to also deal with spawning the views, attaching them to the DOM, and then removing them from the DOM when your fragments are also being removed from the DOM. Because fragments views are automatically managed by OTC. But if you don't have a view panel system, you'd have that your extra views or pop-ups are not part of the view management. And that will bring an overhead or new challenges to how you write your code. Now with view panels are now attached to the view management system. And we'll do view panels later, practically. And you'll be able to see that you can freely quote unquote render new views, and then have OTC when your fragment is being removed because of a route change. OTC will automatically also detect that you have a view panel, or it's a dialogue that had popped up. It will be able to also remove that dialogue from the DOM automatically, and also clean up the views for the fragments. Now, the next big bit of Oats is in terms of reactivity and data management. Now, this is the needed feature in any modern web framework. You need a way in which views, you can not only render views, but also have them be dynamic and reactive to data changes that are either sourced from the server or based on internal app logic. Now, for Oats' case, we use something called the data manager. The data manager is a utility that allows you to tie data and your server resources and your client views together. Or in other words, you can tie your data, internal data and what you're getting from the server, and your fragment views or view panel views together. Now, let me use a practical example. If you come to VART Solutions, now let's navigate to blog. You can see the blog loads, the blog fragment loads, and then you have a loading animation, and then you have the blog content coming. Now, when it comes specifically to where you have more green discourse, on the right side you have a category selection, a couple of radio buttons. Now, if I'm to select sustainable tourism, you'll notice that on the left side, we're able to load new blog content that's specific to the sustainable tourism category. If I to change this to environmental laws and practices, the same thing happens. And if you notice, we have a loading view that shows, and then the content comes in. And when I change the category, the view is cleaned up. You can go to eco-friendly products, the previous view is cleaned up, the loading view comes back in, and then our new content is loaded. Now all this is happening through the data manager in combination with the view managers and something called the network interface. Now, the data manager will primarily handle the data for you. And what that means is it's the only source of truth as far as your web app's data is concerned. Any form of data mutation that you want to do within an Oats web app will be through the data manager. You'll request for it through the data manager. And the data manager will basically hold an array of a model, of which a model is basically an object that can have arrays nested within. The object can be as simple as JSON objects typically are, because that's the standard format for exchanging data between servers and clients on the web. And what the data manager will do is it will, when you give it the model, like for instance, if we take in the article, we have this model right here, where we have a couple of keys and their values, and some of them have arrays within, and some of them are arrays of objects. Now, the data manager will not work by treating the model in its entirety. It gives you fine-grained control of your data by scoping it. And what this means is, we'll have, for our example, for instance, we will have the scope model root, of which the scope model root will refer to the entire object or model. And then we'll have several other scopes, which are my simple object, object.overarrays, object.objectarrays, object.objectarrays, object.objectarrays.array.object key, for the example that you've given. Now, if you see how these scopes are broken down, you've already specified that model root is for the whole model, and then you have my that refers to a string, and that's because inside our model or main object we have the key my that points to a string value, and then you have simple that points to a number, and that's also a scope for the data manager. We have object obj that points to an object of keys of array that has the keys of arrays and object arrays. And so having the scope, when the data manager breaks the scope to obj, that's the data type that it's referring to. And then it even gives you the scope. The scope goes deep into the nesting, which means that we can also have the scope of object.overarrays, of which now it will point to an array of numbers, and then you'll have object.object arrays, of which in our model it will point to an array of an object that has the key object key, and then it will nest it will scope further into this object, and we'll have object.object arrays dot array dot object key, which is this key right here, that will be of the value string. Now what scoping does is that it means that when it comes to your data mutations, you can scope the mutation or data changes, meaning if I was to tell the data manager to make a data mutation and I give it the scope model root, what it now expects is that we are going to change something in this entire model. If I was to change that scope to my, it will mean that the data change will be specifically for this key, my key, and whatever value or data type will be changed will be a string. Same thing for simple, same thing for obj, same thing for the rest of the scope. And if you come specifically to the last scope, object arrays dot array dot object key, you see this value right here, or this bit of the scope dot array. It tells the data manager that we are going to act on a scope that is within an array, and there's some values that we give to the data manager that will help it to locate this array, index it, and get to the data specifically. And these are things that we'll be looking at later, and we'll be looking at the data manager in its entirety. Now, the data manager, as we've explained so far, is the source of truth as far as your data is concerned. It's where your data mutations are done. You can view it as your database, as your internal database. But then your web app is running at the client. And what this means is there is data that it needs to source from the server or an external resource. And then this data that the data manager holds needs to be, there are bits of it that need to be rendered to the client in the web app. Now, the data manager will not work alone. The data manager, if you look at this diagram right here, the data manager will work in combination with a network interface and a view manager. Now, what the network interface does is that it allows the data manager to access an external resource and source data from there, or synchronize its internal model to the external model, in the sense that, let's say the user is filling up a form, and as they're filling up a form, we are putting those details inside the data manager, inside the data manager's model. Now, when the form is complete and the user hits submit, the data manager will communicate to our external resource, which is our server, through the network interface, and now push the information that has been provided by the user at the web app, in the web app, to the server. And that is how now it will synchronize whatever it has, the model that it has, with what the server contains. And if, let's say, we are displaying something like in Vat's example, when I switch to, let's say, sustainable tourism, what it does is it clears its own model, and because what it needs to show is what that server holds, the data that server holds, the data manager will communicate through the network interface to our server and ask for new data or to load data. And the network interface will deal with the communication, the network communication. And then once that's done, it will pass the result to the data manager, and the data manager will commit it to its own internal model. And when all this is happening, this is where the view manager comes in. The view manager will now reactively show these mutations or changes to the user. Now, let's take VAT's example. Let's switch again to a new category. Now, I've come to environmental audit, and you can see the message is you are yet to pen something here. Now, what has happened is we have requested for data from the network interface, and as that was happening, you saw a loading screen pop up because the view manager, there's a view manager that is attached to the data manager, and that view manager is in charge of the view that we have right here under more green discourse. Now, that view manager will be informed that there's a mutation that is happening and you are loading new data. And there'll be hooks that, as the developer, I will have attached to the view manager. And those hooks now will communicate that we're loading new data. And on my end, I will show the loading view. And now, when we have received the new data and the data manager has committed the data manager will broadcast this change to the view manager. And the view manager now will fire the right hook, and I will be able to capture that hook as the developer and then provide the view that I want to be rendered based on the data that I've gotten from the server. Now, for the case of right now where we are green business, when I got the server responded with the data, the data manager committed, and the view manager got a broadcast from the data manager that now we have a new data commit, and it was the view manager was able to ask me for the view that I want to render for this data. I gave it the view as a HTML string, templated from the data that is gotten from the data manager, and then it attached it automatically. And for the case where we were at, I think it was environmental audit? Yes, we didn't get any data, and still the data manager broadcasted that to the view manager, and we were able to render the view that we are yet to pen something here. Now, as far as the view rendering is concerned, for the view manager, you don't deal with attaching your views to the DOM or detaching them from the DOM. All you have to do is just provide hooks, and the hooks take the form of onMutate, which will tell you when data is being mutated, and you can request the view manager to load a specific view to show the mutation that's happening. onCommit, which will be fired when the data manager communicates or broadcasts that it has committed the data. onCancel, which is when a network event has been cancelled. We are loading data, we are trying to push some data, and then it was cancelled. You're able to react to this as well in your view manager. onError, in case there was an error, you're able to react to that and provide a way for the user to retry the data mutation or the network activity that was happened in relation to specific data. Now, as far as all these folks are concerned, we'll look at them specifically when we'll be diving down into the tutorials. But basically, as far as reactivity and data management is concerned for OTSI, this is the system that is used. We have the data manager, which is the source of truth. This is like the internal database for the web app. There's a network interface that allows it to talk to the external server, and there's a view manager that receives broadcasts about data changes that from the data manager, and that allows your view to react to those changes or data mutations. Now coming to the last few things, one big thing about Oats is that there's no virtual DOM. Every operation is done by Oats directly to the DOM. And even in the case of view managers themselves have a internal system that allows them to keep track of the actual DOM as is, and therefore we don't have to set up a virtual DOM that we have to sort of sync with the actual DOM so that we can have reactivity or view changes or any form of rendering. everything is done directly. And even you as the developer, you can be able to access your nodes directly and make changes to them directly. And now we come to lifecycle management. For a web app, lifecycle is a big is a big requirement or a big feature that is needed. And Oats automatically does lifecycle management for you, not just at the fragment level where you have your views, but also for network calls and data management. In the sense that if you come back to our data manager example, when your data manager is running, and let's say we are loading new data, like let's take VAT's example, asking for new data, and then it switched to a new fragment. I've just come from blog where we're trying to load new data for a category, and then it switched back to shop. Automatically, the data manager, because it's lifecycle aware, was able to cancel all calls, stop any broadcast from the view manager, because it got the information that we were destroying our fragment, we were moving to a new fragment, so our rendered view is obsolete, and we didn't have to deal with any errors, the web app crashing, because everything is being managed for us internally. Now, this just helps improve the developer experience. So when you're writing your OT app, you don't have to think about when something is alive, when something is being destroyed, or specifically a fragment is being destroyed, or a view panel is being destroyed, or is being rendered. Everything is being managed for you. All utilities that you have for network calls, for data management, fragments, view panels, all of them come with lifecycle management inbuilt. But what if you want to extend the lifecycle management? You have your own libraries, because Oats is supposed to be an open system. You have your own libraries, and you want to use these libraries in an Oats environment. You can extend the lifecycle management and listen to lifecycle events. Basically, how you do this is you'll grab the lifecycle object that is visible within a fragment or a view panel. You just call get lifecycle object. It will give you the lifecycle instance, and then to that lifecycle instance, you can attach listeners, which will have 4 methods, or let me call them callbacks, that will be fired whenever there is a change in the lifecycle state of a fragment or a view panel. And this will be on fragment running, which will be fired when the fragment is running or is now ready to be rendered. On fragment cancelled, which shouldn't worry about in most cases, but is just an internal callback that is used to inform OTC when a fragment rendering has been cancelled, and in most cases because like there's a sudden route change. Like you are, let's say for VAT's case, we were at shop and then went to about and then went back to shop. The previous about fragment was actually being rendered when we navigated to shop. So it was cancelled. It was abruptly cancelled. And we just use that internally. And we have the on fragment destroyed, which is called when now the fragment build has been destroyed. So the reason why fragment cancel shouldn't be a huge concern when you're implementing when you're listening to lifecycle events is because at the end of the day, if the fragment is going to be destroyed, there are times when the fragment is cancelled, but it will not be destroyed. It's going to be re-rendered. But then there are times when it's cancelled and then it will be destroyed. So what you just need to pay attention to is on fragment destroyed, because that will be called when now the fragment is completely, or the view panel is completely going to be kicked out. And now we have on view ready. There's a special callback that is called when the fragment's view is actually ready. It has been rendered. Now, if you have any libraries, let's say you have an animation library that you want to put into, you want to integrate into an OT web app, and in most cases you want to deal with the null pointer exceptions, because let's say you're loading within a fragment, there's an active animation that was going on, and then the user navigated out of the fragment. How will you get to know this? You just extend, you just get the lifecycle instance, you implement your listeners, and then you can be able to do your cleanup or your setup. Your setup when the fragment is run, when you get this call on fragment running, your cleanup when you get the call on fragment destroyed. Now, the other key thing to know about Oats is that its core is OOP based. What that means is Oats itself is written using object-oriented programming paradigm, and that was key in terms of the design to ensure that we have a good way of setting up fragments and cleaning them up as far as even memory is concerned, and also be able to manage internal states in a more logical way. But it doesn't mean that you're completely fixed to using OOP paradigm in all your internal logic for anything outside Oats that doesn't give you the web app functionality, in that you're not trying to know when to render your fragment view or anything of that. So it's just a library. Let's use the animation library for example. You don't have to write that in OOP. Just like we can exploit functional programming and OOP in JavaScript, you can do the same thing with Oats, as long as your library using the functional paradigm is lifecycle aware. You've gotten the lifecycle instance, you can be able to know what's happening to the fragments that are being managed by Oats, so that your library can do the right thing and work well with your web app. Now, we come to server-side rendering. Server-side rendering is also provided by default by Oats, and it happens in two ways. We have the server-side rendering for views, and you have the server-side rendering for data. Now, the good thing with Oats is you don't have to run JavaScript on the server. Oats has a very unique way of doing server-side rendering that now gives you backend freedom. As long as you can render HTML, as long as you can deliver your HTML file and the CSS and the JavaScript that is needed for your web app, as everything else for Oats as far as server-side rendering is concerned is done internally with just a few unique elements that you add to the HTML file. You don't have to do anything for the JavaScript specifically or attempt to run Oats in your server. Now, as far as view rendering is concerned, view server-side rendering is concerned, the only requirement is that your view structure from the server is the same as the app would have rendered it. So for instance, if you have this app render, we have this diagram here where you have the app render and the server render. And you can see that the app render, what the app would have rendered internally, running on its own, is a one-to-one match of how the server has rendered the HTML. As long as what the server delivers as HTML, the markup looks just like the app would have rendered it, Oats will be able to automatically detect that this markup that I'm running through right now is coming from the server. And let me use a practical example. So let's come to blog. And we've currently rendered blog directly from the web app. This is not a server-side render. We haven't refreshed our page. We've just rendered it internally. And since you've done that, you can see that our categories and sustainable tourism, our categories radios are working. Now, if I was to refresh this page, now I've gotten a page from the server. But what we've noticed is we haven't had a loading animation or anything of that sort. This is just a page direct from the server. Oats hasn't re-rendered the fragment because as far as view rendering is concerned, this markup is exactly as the app would have rendered it as far as the markup is concerned. Now, Oats has been able to automatically detect that markup came from the server. I don't have to re-render the fragment views, so we'll skip that step. Now, what about the data? Because our blog is running a data manager, it's reactive. And if I'm getting data from the server, how will Oats be able to know that, hey, this is the state, the data state that has come from the server, and the data manager is supposed to continue from this data state. Now, how that is done is through now data manager hydration. Data manager hydration simply involves providing a script inside at the HTML, at the head tag, inside the head tag of the HTML, where we'll be able to give the data manager or our data managers, because we can have more than one data manager within a fragment or a view panel. We can able to give it information about its model or its model state, and then it's able to pick up its operations or mutations from there. And in our example, if I were to reload this page, you can see when I come to categories, already it knows that you're at all categories, and it has already wired the listeners for the categories, and you're able to navigate through each category and have that load. Now, with this script tag, basically what will happen is the data manager, I'll provide to the data manager the ID of the script tag that has its hydration info, or rather its model state info, and then it will be able to read that info and run it through a few steps, and then finally commit that info and then broadcast this to the view managers that are already attached to it. So even the view managers get to respond to this state that has been sourced from the server, or the server or the server had rendered through this script tag, and then everything is able to start from the right state. Now, because having key information put for a web app put in an open script tag is not exactly a good idea depending on your application, the data manager exposes several steps, hydration steps, that make it easier for you to just be able to communicate the state of the data that has come from the server, and then the data manager to process it. So the first step is validation, to just avoid any cross-scripting issues or any form of corruption. The data manager will allow you to optionally run a validation step where you can validate that the type of data or model info that you're getting from the server is correct. And then after that, you can be able to pre-process it, which means to just convert it into the form or the model that the data manager uses. What that means is your server can actually deliver the model info in a way that is not exactly a one-to-one match with how the data manager wants it, but the data manager will allow you through the pre-processing step to convert it into now the model that the data manager for your web app uses. And then finally, we have a network step, and this is a crucial step because, for instance, let's say the information, let's say it's a e-commerce website, and there is information like product IDs that you don't want this to be exposed in your HTML, which is available for web scraping and available to robots. But it's information that your data manager needs when your web uploads, so that it can provide the right functionality. Instead of exposing that in your script tag, right here where you're doing data manager hydration, you can just provide something like a public ID. There's some random string, but that string, when you pass it now through the network step to your backend server through now a secure API, it will be able now to provide you with the secure information or private information that now you can now finally commit to your data manager, and that will allow the data manager to now run optimally and have your app provide the functionality that it needs to give to the user. So this is just everything that comes with server-side rendering. For your views, it just needs a one-to-one match between what the server has rendered in terms of markup and what the app would have rendered. And for the data, or getting to know the data state, you just need to provide the hydration info, which is just a script that you put at the head. You can have unique IDs so that each data manager can be able to target its own info. And then you can have now the data manager read this info, run an optional validation step, run an optional processing step, and run a final, also optional network step to just make sure you're able to easily communicate from the server the state of your data, and you're also able to communicate that securely or in a way that limits how much information you provide to web scrapers or robots that are scouring the web. And that's everything, or most of what Oats has to give. It's quite a lot, and there's a lot that will be unpacking over time. What is going to happen next is that there are a couple of tutorials that I've already written and a couple more that are in the pipeline that I'm now going to do in a video series. We're going to look next at how to just set up an Oats project, the different ways that are available. And then once you've done that, you're now going to actually do a project where you're going now to start learning the fundamental bits of Oats, the bits that I've mentioned here. We'll do fragments, and then after fragments, we'll do a bit of the activity, and then after that, we'll do a bit of your panels and everything, and just come from top level and go deeper as we go. Now, if you're interested in this project and you want to learn more and you want to see what Oats has to give and probably start building web apps as I was able to build in this case, in that example, you can hit subscribe, give a like, wait for the next video to drop, and you can also follow us on our socials and our publishing pages. Whenever new content will be dropping, you'll be able to get that information quickly, and you'll be able to do this. We'll be able to learn Oats and see where this new technology will push web development moving forward. So and if you also if you love the work, if you're interested in supporting the work, they also support links down there. You can give a little bit something that will get that will help us push the development even further. And yeah, we'll see you in the next one. Cheers.